Here we're going to look at question 75 from the IMAT 2011 paper. So in this question, we're given Newton's law of gravitation, that the force between two objects is given by the gravitational constant g multiplied by the mass of each of the two objects, m1 and m2, divided by r squared, where r is the distance between the two objects. We're also given the gravitational constant g. We're told the distance between the Earth and Moon is 4 times 10 to the 8 metres, that the mass of the Earth is 6 times 10 to the 24 kilograms, and that the mass of the Moon is 7 times 10 to the 22 kilograms. Then the question asks us, what is the gravitational force between the Earth and the Moon? So if you'd like to have a go answering this question yourself, then please pause the video now, otherwise we'll have a go at doing it together. Okay, so this question is actually fairly simple, and all we have to do is plug the values we're given into this equation. Since these all pertain to the situation we're talking about, they have the distance between the Earth and Moon, the masses of the Earth and Moon, and we have the gravitational constant g. So of course we can just substitute these in, and then going through and simplifying them a little bit, we should get that the top is equal to 6 multiplied by 7 squared times by 10 to the power of 35, and on the bottom we have 16 times 10 to the power of 16. Then we can just sort out our powers of 10, of course, and we can cancel out a factor of 2 from our 6 and our 16 to get this as our answer. But this, of course, is not an answer in standard form, which is what we're asked for in the question if we look at our answers we're given. So we need to try and work out what this is going to be, at least roughly in standard form. Now we do see a power of 10 to the 19 on the end here, but that doesn't necessarily mean that our answer is going to be of the order of 10 to the 19, because we don't know the magnitude of our constants out the front here, 3 times 7 squared over 8. So if we do work that out, it takes a little bit of calculation, but we find that it's 147 over 8. Now if we think about 147 over 8, we can see fairly clearly that it's going to be greater than 10, which of course means for it to be standard form, we're going to have to take a factor of 10 out of this constant out the front. So that's going to make this a 10 to the power of 20, or our answer of the order of 10 to the power of 20. And if we look at our answers, we can see this is going to have to correspond to the force being 1.8375 times 10 to the power of 20 newtons. And this answer is, of course, going to correspond to answer B, which we're given in the question.